All right, so Professor Brown already stepped you through the subnetting application portion on how to build your networks using the math piece, but he did not cover the routing piece with you. Now, I'm going to cover the routing piece with you, but I won't be able to show you how to do the VIATA. If we are in school, if we have class on the 12th, we will do the VIATA piece, but what I'm going to do is I'm going to show you how to do this whole thing in Packet Tracer, plus it'll also give you a tutorial on how to do it in Packet Tracer. So, come over here. I already have Packet Tracer installed on my machine. I'm going to load it up. Now, you don't have usernames and passwords for Cisco, so you're going to have to log in as a guest, and I'll see if I can simulate that. My computer might automatically log me in as a, there we go. So right down here, you see we have a guest login. We're going to go ahead and click that. Usually makes us wait for a little bit on how to do it. Let's see if we can get back over here. Okay, now I have to confirm my guest. And now I'm in. Okay, this is the Packet Tracer main window. Now, if you can see down here, we have a list of our network devices over here in the lower left. And then we have our end user devices like tablets and printers and laptops and workstations. Different components that we can put into some of our devices. This lightning bolt here, these are our connections. I'm going to have us do it a certain way today so you can simulate how we really do it. Okay. Any miscellaneous folders or files you might have. Down here we have our routers. Okay. Because see, my network is selected. So my routers, my switches, my hubs, which we don't really use, wireless devices, security appliances, and let's never forget the WAN emulation for the cloud, all sitting right here. Okay. With my network devices selected, I'm going to come over here and you see I have routers selected, and these are the different types of routers that I can actually program. Now we have, I do believe, the 2811s, not 100% sure, but we're going to pull one of these up here. I'm going to select it, I'm going to drag it, I'm going to put it up here, just like that. Now, I just want to do a real quick check. I want to find out what components are actually on this router, so I can just do an inventory to find out did I bring up the right one. So bear with me here. Okay. When we bring up our router, okay, it always says, would you like to enter initial configuration dialog? We're going to choose no. Some of you last week chose yes, and then it started prompting you to put in passwords and everything else. Interface brief. Doesn't like that. Oh, because it's my show IP interface brief. Okay, so this one has fast Ethernet, so you're going to want to go ahead and choose the 2811. So let's build a network the way that Professor Brown had built it for us. Remember, he's using a 172.16 network. He borrowed 3 bits. To create 8 networks. So I'm going to select my switches now. I'm just going to get a regular 2950 24 port switch. Put that one there. Take this one here. We're going to get some connector. We're going to connect these bad boys together. So I select the lightning bolt here. And this is my fast Ethernet cable. As you can see down here at the bottom, it's going to tell you the type of cable that I have my mouse over. So this is my copper straight through. These are my crossovers, fiber optic cables, okay, a telephone cable, coax cable, my serial DCE, which is the one, if I were to use this one, I would have to give it a clock rate. My serial DTE, which is the opposite end. Okay. I also have my octal cable, a custom cable, USB, and then most importantly, this is my console cable. So if we're going to simulate exactly how we do it in a classroom, we're going to use a console cable today. So first, let's grab our Ethernet cable. just like you guys do. I'm going to plug this one here into my 0, 1 port, drag it over to here. I'm going to plug this into my 0, 1, so they're both the same. As you can see right here, both these interfaces are down. Okay. Then I'm going to take another Ethernet cable, plug it into my G00 port, and I'm going to plug this into my Fast Ethernet 24. Okay. I'm going to do the same thing over here. And plug it into my 24 port. Now we're going to apply. So now I have my 1, like right here, this is network 1, this is network 2, this is network 3. So let's go ahead and give ourselves the labels so that we can call them layer 1, 2, network 1 and 2, and so on. So I've got my drawing applet here. Not the one I want my text. I want to give it a label here, folks. All my toolbars are up. One sec. Alright, so let's see here. Let's make this guy here network 1. And network 1 will have the IP address of 172.16.0.0 with a subnet mask of 255.255.224.0. Network 2 will be 172.16. Now remember we had 5 bits remaining in the third octet here, so we're going to be in multiples of 32. And our final network here, which will be network 16.64.0 with a subnet mask of 255.255.224.0. All right. So now we're going to want to give ourselves some end devices. So we select the end device here. We're going to put a couple PCs here, just like we would if we had our other networks. Grab another couple PCs here. Then we're going to connect these guys. Now, most people would have put there, you can put it on 2 if you want, but I'm going to put mine on 6, and the reason I'm doing that is because what if later on I decided I wanted to VLAN this one here, because I might move on a little bit higher over this lab and give myself a different VLAN inside of here. Room for expansion. It's up to you. But for the main purpose of this lab right here, we're just going to go on 1. Oh, my bad, hang on. And 6. Okay. So now, in essence, my network is built. This guy is going to be here on 172.16.0.10. With a subnet mask of 255.255.224.0. The default gateway is going to be this guy here. So this is my network 1. If PC0 here wants to leave network 1,
he's going to have to go through this interface right here, the router. So that is called a default gateway, and that will be 172.16.0.1, and we'll just give that a, okay, we don't have to give it an IP address right now, so make that a 1. Okay, so there's my default gateway. This is label these so we know what we're doing. Address, make it a colon, make it a little bit more intelligent. Okay, this is my subnet mask, and this guy is going to be my default gateway of 172.16.0.1. Okay. And we gotta give this guy here an IP address. If he's 10, we might as well make him 11, right? So let's do this. Because he's part of the same network, he's gonna have the same default gateway as the other guy, right? And we're gonna come over here. This guy's gonna be 64.0. So let's create another box. So 64.10. And his IP address is going to be 64.1, right? Copy that to my clipboard. And the only thing we need to change is 11. We cannot have two hosts with the same IP address on the network, or we will have an IP conflict, and that would be very bad, actually. Okay, so now as you can see, we're green going up here because by default, all switch ports are up. And as you can see up here, we're down because by default, all router ports are down. All right. So now we're going to do some programming. Well, remember, in order to program an initial configuration, first router configuration, we must always console in. So we're going to take this guy here, the console port. We're going to plug it into the RS-232, which is a serial port. And we're going to take it all the way up to here. We're going to plug it into our console port. All right. Then we'll come down here to simulate the actual configuration, and we want to terminal in 9600 bits per second, okay, 8, none, 1, and flow control is none. Choose OK, right? And now we're in our router, just like we would if we were on a regular screen. It looks just like our putty screen, does it not? Right? So the first thing we want to do is we want to be able to configure this interface right here, which is the one we're plugged into. Remember, we did G00 up top. Okay, so let's go ahead and make some labels for that. Move this over to here. Keep everything organized. So we'll say G0, or sorry, we have fast Ethernet here. So FA0/0 will be 172.16.0.1, and we'll make that a slash 16 and 3, so we have 19. Okay. Let's move that out of the way a little bit. And the other one is going to be the FA0/1, which is going to be 172.16.32.1/19 also. So we're going to take that one, we're going to move that to here. Take this one, move this one to here. Then we're going to create another text box here. Okay. Remember, these guys here are on the same network. They can only communicate with each other if they're on the same network. So FA0/1
colon 172.16.64. I'm sorry, we are 32 network here. 32, okay, .2, which will allow them to communicate with each other. And that'll also be a /19. And on this network here, it's our 64 network, we have a 172.16.64.1/19. So now we have all of our IP addressing set up on how we're going to program our network. First thing we can do is we can jump in. We're going to jump into the FA0/1 network. As you can see, it has not been programmed yet. Back over to here, and let's enable. Now you can see I can use shortcuts, so I can use EN for enable because there's no other word at this point, no other keyword that begins with EN. So I can say EN for enable. I'm going to configure, so I can cut that short. Configure terminal, conft. Now I'm going. First command I want to do is I want to label my router. So we're going to call this one hostname R1. Okay, and as you can see, our command prompt has changed to R1. First thing we want to do is we want to be able to program, apply. We take our one network, we broke it into 8 networks, so we're going to program the first network, which will be on interface FA00. So interface FA0/0. You'll notice my prompt has changed again to config IF. Now I want to do an IP address. Now let me give you an easier way to remember this. We can, instead of doing IP address, what we want to do is we want to add an IP address to this interface, right? So why don't we remember it by saying IP add 172.16.0.1 must be paired with a subnet mask 255.255.224.0. Okay, and by default, remember, all interfaces on routers are down, so we want to run the no shutdown command. And as you can see, it's up here. We're running an ARP right now on the port 24, which would be our trunk port if I was VLAN, and that'll turn green here in a brief moment. Okay. The next interface that we need to program is right here. It's the 172.16.32.1, the other network. See, we have to go through this router in order to be able to talk to this network here. So we're going to program FA01 and make that the 32.1 port. So I don't actually have to type exit here. I can actually type the interface command FA0/1, and I'm actually now in the FA01 interface. The prompt does not change, so it can be a little confusing, especially if you're not paying attention. Make sure you don't get a typo right here. I'm going to IP add 172.16.32.1 with my subnet mask. And then do a no shutdown command. Now there's one thing I didn't do that I always do on my routers when I first set them up, is I do a no IP domain dash lookup. Some of you have noticed that when you make a mistake when you're typing in your syntax, and then you'll get an error that says translating, this will come up. So here, let me just see if I can simulate that for you. So let's just do, I didn't like that one. Let's try, of course I can't make an error when I want to, right? There we go. See, this translating. See, I have a typo. It's translating domain server. It's going to keep on going. The only way to get out of it is to do a Control-Shift-6, and it makes it stop. or if we were to do get a configure terminal mode and do a no IP domain dash lookup, okay, now if I do that command, it just says unknown. So it doesn't have to go out and do the no IP domain lookup. So this router, in essence, is already programmed, ready to go. Okay? If I shut this router off, I'm going to lose all my information. So I want to do a copy, run, start, which is short for copy running config to startup config. Everything we're looking at right here in RAM is my running configuration. On boot up, after the router runs its post, on boot up, it'll then search for and locate the startup configuration, which is the programmed piece of the router. So we have to make sure that we always have our information in there. So when I hit, so what I did is I hit enter, then it confirms it, destination file name, startup-config. If you type anything else in here, it'll create that file. So if I were to type yes, it would put my startup config in a file called yes. You use this right here with the loan, with the loan in here in the brackets. That is my default. So hit enter, builds a configuration, puts it in there. And let's go ahead and get out of this. Now we have to program this router. So let's grab another console cable, plug it into the RS-232, plug it into the console cable here. Come back down to here, go to my desktop, choose terminal, choose OK. Would you like to enter initial configuration dialog? Always say no. Okay. Now you notice I don't have a default here because I have a yes/no. So this one here I have to choose. So I choose no. Press return to get started. Okay, you'll see I'm in a blank router. We're going to call this router router 2. Oh, what did I do wrong there? I forgot to type config t, then hostname R2. And I'm going to go into the interface of FA0/1, which is on my 32 network. I'm going to do an IP address 172.16.32.2, the subnet mask of 255.255.224.0, doing no shut, and that one's up. Okay. I'm going to jump over to my interface FA0/0. I'm going to do an IP address of 172.16.64.1, the subnet mask of 255.255.224.0, no shutdown, exit, no IP domain dash lookup, make my life easy. I copy my running config to my startup configuration, confirm it by hitting enter, and we're good to go. Now if I take a look, I do a show IP interface brief, and you'll see that I have my two interfaces programmed. They are up, and we are ready to go. Right. So now, if I want to, I should be able to ping my default gateway to make sure it's working. Okay, does anybody think that it's going to work? I'm going to say no. Okay, We missed one very important step in here. Okay, our DHCP is set up for static. We just set it up 172.16.0.10. Repair the subnet mask to 224. Give it a default gateway of 172.16.0.1. Don't worry about DNS, and at this time we're not going to worry about the IP version 6. Okay. So now, if I come back in here and get my command prompt, I can ping my default gateway without problem. Okay. Come over to this guy here. Let's go ahead and program him. To an IP address of 172.16.64.10. Don't forget your default gateway, or you'll never be able to leave your network, 172.16.64.1. Okay. So the question is, can I now ping the whole way across? Let's find out. Can I ping my gateway first? Okay, we can. Can we ping the next interface on the other side of the router, which will be 32.2? We can. Can we ping its neighbor, which is 32.1? We cannot. And let me explain to you why we cannot. Okay? Being able to ping one's router is a simple task. But routers talk to other routers using routing protocols. So we have a choice. Now, based on the lab, we probably have either RIP going on here or OSPF. Now, I'm not really sure why we use RIP, or Cisco even teaches RIP anymore, when OSPF would be the more scalable routing protocol of choice. So we're going to back into this guy here, hop onto our terminal, choose OK, and then we're back into this screen. So now we're going to get back into configure terminal. We're going to run a command called router OSPF 10. You can use 10, 2, 1, doesn't matter. This is just a system number that we're using to identify. Both of our routers are going to have to be able to communicate to each other, okay, on the same system. So now you notice that my routing prompt has changed to configure router. We're going to say network, and we're going to put in the networks that we want to have advertised. So we're going to advertise our two networks. Our two networks are 32 and 64. So we're going to advertise 172.16.64.0. Now what follows is something called an inverted subnet mask. So what is an inverted subnet mask and how do we make one? Well, we know our subnet mask is 255.224.0. Okay? So to come up with our inverted subnet mask, we want to subtract that subnet mask from all 255s. So if we do that, 255 minus 255 is 0. That's 0, right? And then 255 minus 224 is 31. And 255 minus 0 is 0. So my new inverted subnet mask is 0.0.31.255, which takes me back over to here. And we say 0.0.31.255. Okay? And hit enter. Incomplete command. Because in OSPF, the central home network that we work on is called Area 0. All network traffic must return to Area 0 before it heads out and does any more work. So, Area 0. Okay. Basically, we're going to repeat the same command. The only difference is now we have to put in our 32 network. Got a few emails coming in over there. Okay. So we can go ahead and get out of this screen, come back over to this screen, look at this terminal, choose OK. And we're going to pretty much do the same thing over here. We're going to run router, OSPF, 10, because that's the one we use in the other one. You'll see our router prompt has changed. We're going to advertise our two networks on this one. So network 172.16.0.0. Okay, and our inverted subnet mask, which is the same, which is 0.0.31.255, all going back to Area 0. And this guy also knows about network 32. And you'll see that an adjacency has just come up. Now I know in some labs we will tell you to go ahead and redistribute connected, but in reality we don't need to. Okay? So there are certain commands we can use for redistribute. Like if I needed to put a default gateway on this computer and this router here, so that the other routers knew how to get out to the internet, then I could redistribute that gateway as well. So let's do a show IP route command, and you'll see that we just learned about the 64 network. We didn't need to learn about the 32 network because we're already directly connected to it. And we didn't need to learn about the 16 because we're already directly connected to it. But what we don't know about, okay, was this network here. So how are we going to learn about this network unless this router shared its information with us? So if we go back to here, you'll notice that an adjacency was created, okay, meaning it's saying, I just learned, okay, about another network from this interface 32.1. So now on here, if I were to do a do show IP route here, I now know about this network because this guy told me about it. So now I should be able to do what I couldn't do before. Remember, I couldn't ping. No, I wasn't using that one. Hang on. I couldn't ping all the way across, could I? Remember? Timed out. So what if try now. Now, as you can see, I can ping the 32.1. So I should also be able to ping my 0.10, which is this host right here. And I can. So we just built the entire network, and we used OSPF. The only difference in this lab and the one that we do in-house is that we will make this the VIATA. So instead of using IP add, we will be using set interfaces. But other than that, it's pretty much the same thing across the board. Now, if we don't have class on Tuesday night, I want you to submit this packet tracer to me. So you'll come up here to File. You will do Save As. I want you to save it as a PKT file. You will call it Subnetting Application. Save it somewhere where you're going to remember it. I'm going to just dump mine in my Documents folder. Okay. Choose Save. Okay. Because I'm on as a guest, I only have 3 saves available, but that's okay. So I save it. Then I can go to D2L. We'll set this up for you now. Or not. Then you can go to D2L and then you could submit that for me, and I'll create a Dropbox for you. Okay. I only expect to see this in your Dropbox if we do not have class on Tuesday night. Else we're going to do it in-house. Okay. But the application has been posted for you with explanations of how OSPF, the routing protocol, works, and some shortcuts in Cisco. So I hope you enjoyed our wonderful little lesson we did here, and good luck.